Oh, sorry. Sorry, just enjoying the day here. Class is beginning. Not ready for this. Holy cow. Thanks for your patience, guys. Hope you're having a wonderful, glorious day today. Hope you're ready for math instruction today. Compound inequalities. What it means is it's an opportunity for the math teachers to give you two problems in one. That's all it is. Compound inequalities. We'll get there. It means compound means two or more. So it's just a way for us to give you two problems in one. It's about combining inequalities in a couple different ways, and we'll show you how those are. But we'll spend a few minutes together. I'll explain the concept. I'll do a few examples, and then the time will be yours to do the quiz. Hopefully you'll do all right. It won't take too much time of your day to get this accomplished. As always, you can pause, repeat, skip ahead, use the closed captioning, use what you need to understand this concept. So, compound inequalities. On compound inequalities, you're going to see a couple different types. You're going to see them either written and or. You have one inequality and another inequality, or another inequality or another inequality. And here's what they mean. The and inequalities means only where the two inequalities intersect or where they're both true. It's only where they overlap. It's where this and this are both satisfied. The conditions are both satisfied. You'll see it written in future years. You'll see it written with what looks like an upside down U. It's not a U because I've used the next one down. But that's what and means. It's where both conditions exist, where the and is satisfied. The other one you're going to see is an or. This inequality or another inequality. What that or means, it can be either of them. Either is true. Only one of the inequalities has to work. The or simply means it can be this or this. And if you're thinking in your mind that it can be either of them or this one or this, then you'll always understand that it's going to be everything. And we call that the union because we include everything from all both inequalities. Sometimes you'll see them combined. You'll see them written something like this, where the inequalities are combined. That just means an and. This inequality has to satisfy with the -8, and it has to satisfy with the 6 at the same time. It's just an and problem. So go ahead and take a few seconds if you want, hit pause, and write down maybe some notes that you can look at. So there you go. Go ahead and take a second and write down whatever, if you want some notes that makes the most sense to you. Okay, we'll go ahead and we'll work through a couple problems using this and or and combined. I'm going to work through numbers 1, 3, 4, and 7. I can find them. Okay, I mentioned it's two problems in one. Here's how much fun we're having on this. Come on, here we go. We're going to solve each compound. Then we're going to graph it. Then we're going to write the solution in interval notation. So 3 different steps on these problems. That's why I'm only going to do four problems, because it's now 4 because it is. And you can look at the other ones. If you want to try some more, you can look at them on the answer key provided. So first we solve the compound inequality. So right here we're going to solve this. We're going to divide both sides by -2, which leaves p, and -8 divided by -2 is 4. And remember, when you do that, you have to flip the inequality, so p is less than 4. You'll notice I'm not spending a whole lot of time on work we've already done. I'm not showing a whole bunch of steps. Maybe I will on some of these, but the process we want you to learn today is the and, the or, and the combined. On this one, we're going to add 4 to both sides. We do the opposite of minus. So we add 4, keep the sign the same, and -10 plus 4. When you work that through, you get -6. And this is an and. In future years, you'll see them use that symbol right there. So where is p less than 4? That part right there. And it's greater than equal to -6. That means it's a closed-in dot there. So where does it happen where it's and? That means where they overlap. Where do those two overlap? Now this arrow would go all the way down, but they only overlap in this area right in here. That being the open circle, because it's only a less than, and this being a filled-in circle over there. All right, I've solved it. I've graphed it. Now I'm going to write it in interval notation. The -6 is included, so I use the brackets, because the brackets is you include it. And I've shaded in the comma, I've shaded in everything up until the 4, and I don't include the 4 because it doesn't have an equal to. There it is, solved, graphed, and interval notation. That's an and problem because they overlap. Excuse me, I got some wonderful cookie in my mouth. What are you guys eating today? What are you doing while we're working on this math? Now the or, that's not the overlap. We're just going to include everything. We don't have to include only where it overlaps. We include all options. So on this one, on this part of it, let's say I've got this -8 that's attached on. So I'm going to add 8 to both sides. When I add 8, that becomes -5. -13 plus 8. Or, let's see, on this one, I'm going to -8. That's a +8 right there. That's a +8. So I'm going to subtract 8 from both sides so that -m, that negative is still there, less than or equal to 7 minus 8. You can use your calculator if you need. -1. And then to get that -1, we don't write the 1, we're lazy. To get that -1 off, we divide by -1, which leaves us with m. Flip the inequality, greater than or equal to 1. There we go. So it has to satisfy that, or it has to satisfy that. I've solved it. Now to graph it, I want all the numbers less than or equal to -5, less than or equal to -5, or all the numbers bigger than or equal to 1. Let's see, here's the 1. Equal to means I do a filled-in circle. Bigger than or equal to -1. Solved it and I've graphed it. Now to write it in interval notation. Write this one first. So the biggest number here is -5 and it's included, so it's a bracket. And right here, let's see, it goes all the way down to infinity, which we never reach. This one, it's an or, and we use the symbol, the union, because it's going to include all of them. Let's see, 1, so it includes 1. And it goes all the way up to infinity that we don't reach. Solved, graphed, and interval notation. So that's what it's looked like. This is what it looks like when it's there we go. And with an or. Sometimes these overlaps or these separations, you'll end up where you include all of them. But just know that the or means you include everything. The and is only where they intersect. And sometimes they may never intersect. Sometimes they may overlap where it's the entire number line. But as long as you, from those notes, remember what and or means, you're set. Okay, number 4, here's one of those combined ones we're talking about. To solve this to get n by itself, I can just subtract off that 2. And I can subtract that 2 off of all the way across. If I subtract 2, subtract 2, subtract 2, like a 3-way representation, would say equation. If we had 4 equals 2 plus 2 equals 8 divided by 2, I could subtract 2 from all of those and I'd still get the same number. It'd still be the same thing. That's what we're doing here on this inequality. We're just subtracting this positive 2 all the way across. So that becomes a -10 less than, so let's see, subtract the -2, that's n is by itself, less than or equal to 7 minus 2 is 5. All we've done with that inequality is we've just shifted it down 2 on the number line. That inequality was related to -8 and 7. We've just subtracted off. We've just shifted the whole thing down 2 spaces. So there's the solution. if you find sometime in the later, someone might write, well, it's where n is greater than or equal to 5 and where n is like this to -10. You might see someone break it up into the and statement. I like, for simplicity, just keeping it as it is. Okay, so we've got 5 over here, and it includes 5. We've got -10 over here, and it does not include 10. And it's everything in between. It's where they overlap. If I would have mapped these two and then found where they overlapped, I would have gotten that graph. I've solved it. I've graphed it. Now to write the interval notation. Don't include -10. It's not included, so the parentheses. I've shaded everything in. That's the comma in between the 5, and I do include the 5. Solved, graphed, interval notation. Last one, number 7. To get k by itself here, we're going to add 10 to both sides. So k is less than, what is it? Awesome. That's exactly right. Well done. -4. And your calculator can show you that if that's not what you were thinking. Or divide by -9. K, let's see, -45 divided by negative is 5. And what do I do with that sign? Every time that you divide by a negative, you flip the inequality. So k is less than -4, or k is greater than 5. Include everything. It can be either of those. So let's see, less than -4. Less than -4 looks like that. Open circle at the -4. Right here, another open circle at 5. And everything greater than 5. There it is. And then to solve that, on the interval, it's parentheses on both of them, -infinity. And then up here is -4. And then or, you use the union symbol, the U symbol, or everything from 5 to infinity. There you go. As I wrote that right there with that -infinity, I kind of realized, oops, pretend you didn't see that, pretend that didn't occur, another Mr. Larson mistake. -infinity down there, not positive infinity. Oops, sorry about that. I'm too busy thinking of these chocolate chips. Okay. If you wanted to solve this one, just multiply all of these by 10. -1 times 10. 10. This times 10. The 10s and 10s go to 1, so it's just plain old n. And 0 times 10. Still 0. And then you just map that out the same way. All the numbers between 0 inclusive and -10 not inclusive. And that's what I'm doing too much. I'm spending too much time. It's almost been 15 minutes. That's too long. Hope this makes sense. Hope you did well. Go ahead and try a couple others of these if you would like. Remember, there's negatives on the x. You have to flip the inequalities on that. Be careful on that one. If you try a few of these and then work on the answer key. And good luck on the quiz today. Thanks for watching. Have a wonderful, enjoyable, I hope, snack-filled day.